Infrared radiation is a type of electromagnetic radiation that is closely associated with heat. Every object, regardless of its temperature, absorbs and emits infrared radiation. This radiation is part of the spectrum of energy that is invisible to the human eye but can be felt as warmth. The amount of infrared radiation emitted by an object depends on its temperature. The hotter the object, the more infrared radiation it emits. All objects continuously emit infrared radiation as their atoms and molecules move and generate energy. Cooler objects emit less infrared radiation, while warmer objects emit more. For example, the sun, being extremely hot, emits a large amount of infrared radiation, which we feel as heat on our skin. On the other hand, a cold object, like ice, emits far less infrared radiation. To investigate how different surfaces emit infrared radiation, one common experiment involves the use of a Leslie cube. A Leslie cube is a metal cube with different surfaces, typically shiny, matte, black, and white on each of its sides. The cube is filled with hot water to ensure all sides are at the same temperature, and then the infrared radiation emitted from each surface is measured. In the experiment, an infrared detector or thermal camera is used to measure the intensity of infrared radiation emitted from each side of the cube. The results typically show that the different surfaces emit different amounts of infrared radiation even though they are at the same temperature. For instance, the matte black surface, which absorbs and emits more infrared radiation, will show a higher reading than the shiny surface, which reflects more radiation and emits less. This experiment demonstrates how the color and texture of a material influence its ability to emit infrared radiation. Dark, matte surfaces are more efficient emitters and absorbers of infrared radiation compared to light, shiny surfaces, which tend to reflect more radiation and emit less. This principle is applied in various practical situations, such as designing radiators and heat sinks, where efficient emission of infrared radiation is desired, or in insulating materials where minimal emission is preferred to retain heat. Understanding how infrared radiation relates to temperature is crucial in fields like thermography, where infrared cameras are used to detect heat loss in buildings or monitor the temperature of machinery. It also plays a role in everyday technologies like remote controls, which use infrared signals to communicate with devices, and in safety systems like thermal imaging used by firefighters to see through smoke. The study of infrared radiation and its interaction with different surfaces helps us harness this energy in both practical and innovative ways.